Hello everyone. In this video you're going to make a virtual lab to study more the temperature and thermal energy and how they are related together. And we're going to make the experiment as we learned before. We want to put the hypothesis at the beginning. You have to put your answer question, then you have to write your prediction, then we're going to investigate if our prediction is correct or wrong. Before we start, let's answer this
Let's say you want to boil 2 eggs. You have 2 bowls, 2 eggs, and some hot water that has the temperature of boiling water, 100 degrees Celsius. You decide to put 1 egg into each bowl and pour some hot water over each egg. You pour 300 milliliters of hot water in a bowl with 1 egg and 600 milliliters of hot water in another bowl with the other egg. You wait for 15 minutes while the water cools. What do you think will happen to each egg? Click the correct statement, then click OK.
Okay, let's see what is the correct answer. Is it the egg in 300 milliliters of water will be more cooked, or the egg in 600 milliliters of water will be more cooked? Both eggs will have cooked at the same amount. Think about the thermal energy, think about the number of particles were more. So for me, I'm going to pick this one. Let's see if it's correct or wrong.
That's right. The temperature of the water in both bowls is exactly the same, 100 degrees Celsius. Even so, the egg in 600 milliliters of boiling water will cook more than the egg in 300 milliliters. In this lesson, we're going to find out why.
Okay, we want to see why. Okay, let's continue.
Molecules in a substance, like water, are always in motion. Molecules have kinetic energy, the energy of motion. The temperature of a substance is the average kinetic energy of all the molecules in that substance. On the other hand, the thermal energy of a substance is the total kinetic energy contained in all the molecules of that substance. So, given the same temperature, the more molecules that are in motion in a substance, the more thermal energy it has. So, in the cooked egg example, which bowl of water has less thermal energy? Click the correct statement, then click OK.
To answer this, you have to think about the factors that affect the thermal energy. So here the number of particles we want to think about. Here, because 300 milliliter, it has less particles, so I guess this one, it's gonna be the answer.
Good job. There is less thermal energy in the bowl with 300 milliliters of boiling water. As a result, the egg in this bowl will cook less in 15 minutes than the egg in the cup with 600 milliliters of boiling water. This will happen even though the water temperatures in the 2 bowls are equal.
Let's continue now to do our virtual lab.
In this investigation, you will analyze the changes in average kinetic energy, or temperature, that occur as thermal energy is added to the ice. Will the temperature always rise as the ice turns to liquid water and then to water vapor? If not, what will happen? Make a hypothesis. Type your answer in the box, then click OK.
Okay, let's ask our question or to put our hypothesis. What will happen to the temperature as thermal energy is added to the ice over time? For example, if you have this experiment, you have the speaker and you have ice in the speaker, and you start to warm up this beaker and start to give it a heat energy. Okay, what's gonna happen to the temperature? We want to know this. First, write your hypothesis. What do you think? What do you expect at the beginning? Okay,
continue to see if your prediction is correct.
Now we want to see if your prediction is correct or wrong. Okay, you have to write, then at the end, by the end of this experiment, we will see if your prediction is correct or wrong.
Write your plan for analyzing the changes in kinetic energy, or temperature, that occur as energy is added to ice to change it from solid to liquid. and then to steam. What things do you need? What actions will you perform? Type your answer in the box, then click OK.
What are the things that I need? I need first thermometer for sure. I need a beaker, it has like ice inside it. I need a source of heat, thermal energy, which is a Bunsen burner here. I want a timer to see how it will change, and I want to see the change of the temperature. I want to make like a graph here, the time and the temperature as how it will increase by the time. And my plan now, I'm going to turn on the Bunsen burner, then I'm going to measure the temperature of it and to see how the state of matter it will change or not. Let's see the plan.
Check your plan. Did you set a goal and include these steps? Add energy to ice. Measure and record the temperature of the ice, water, and steam throughout the experiment. If your plan does not include these steps, you can change it.
No
Once
worries
you've
here.
finished, click Next to move on.
Okay, no worries. Here I have to add energy for sure. I'm going to use the Bunsen burner as a source of energy, and I want to measure and record the temperature by using the thermometer for sure. Okay, let's continue.
You have the following experimental setup for measuring the change in temperature as thermal energy is added to ice. Turn on the burner to add thermal energy to the system.
The first thing, I'm going to turn on the Bunsen burner. Okay, look, I'm going to turn it on. Before I turn on, look at this speaker, it has ice, and this here we zoom on these particles to look at these particles, how they are vibrating in their place. Okay, and here you have to look here at the timer, and you have to look at the temperature, and you have to see here the graph. Look here, I'm going to turn it on, and you have to see the changes will happen.
Look at the substance in the glass and the motion of its particles. Watch the thermometer and the graph.
Look, the temperature is increased till 0. Look at the movement of particles start to change from solid to liquid. The temperature here is stopped, as you see here, on 0 Celsius, increase till all particles become liquid. Then look, till 0, 0, 0, till all particles converted into liquid. Till now, not all of them, because the graph here is still on 0 and the temperature is 0. Now the temperature start to increase, as you see, when all particles converted into liquid, it will start to increase. Look, by the time, and look how the particles start to be more, they start to move more, and they start to have more spaces between them. Still the temperature increases. Let's continue till it reach, look here, still the temperature is increasing, didn't stop. It's liquid. Now look at the particles start to make the bubbles, start to make now, okay, start to convert it from liquid to gas when it reach 100 evaporation, and the temperature will stop, okay, at 100 Celsius till all particles become from a liquid to gas. Did you see how? Okay, let's continue.
Analyze your data. As energy is added to ice, what happens to the temperature or average kinetic energy over time?
What happened? When I added this temperature, okay, what happened to the particles, the thermal energy? What happened to the temperature when I added heat here? What happened? Write your observation from the experiment. What did you see? Okay, you have to explain this. Let's continue to see.
When energy is added to a substance, the added energy generally increases the motion and average kinetic energy of the particles.
Let's stop. Once you add energy, okay, the motion of particles will be more because they gain energy. So the particle temperature also what increase, the average kinetic energy increase, so the temperature increases. Okay, let's continue.
Temperature increases. When thermal energy is added to a substance that is changing state, for example, changing from ice to liquid water, or from liquid water to water vapor, the added energy is used to overcome attractions between the particles. Thus, the temperature of a substance that is changing state does not increase while the change of state is happening. Once the
If you
change of state
remember, look here. For when thermal energy is added to substance, that change the state. Yani, for example, here changing from ice to liquid, then to steam. So the added energy is used to overcome attraction, because you add energy, they start to move more, so they start to be away from each other. The attraction between them it will be less. Thus, the temperature of substance that is changing state does not increase while, if you remember, during the changing of state, it will not change the temperature, it will be constant till all particles, for example, from ice converted into liquid, from liquid all of them converted into a gas. Okay, once the change of state is complete, the temperature starts to go up, as we saw in the experiment.
Complete, the temperature of the substance increases if more energy is added to it. How does your conclusion compare to how scientists explain this? Type your answer in the box. When you are finished, click OK.
So, is this your expectation from the beginning? Any problem with you, you have to fix it and watch this video again and watch this experiment again, okay? So this is all about our experiment, and you have to make a link between what you understand about the average kinetic energy, which is the temperature, about the thermal energy, about the heat. Make a link and make sure that you understand the main points and the differences between them. If you have any question, you can send me your question. Thank you for listening.